Hey, this will be the last part for web geovisualization. And in this part, I'm going to answer two questions. First one, what do you need to know about web coding? Since you're trying to move maps online, you're trying to make web maps, you need to know some coding tricks and technologies. And secondly, what are some new spatial data types for the web and how can you create them? And in this process, in the third part, I'm going to introduce several technologies. But you should know that I'm not necessarily promoting any one technology over another because different people have different uh, preferences. I'm not saying this one is better than another one or this one is worse than another one, okay? And I think, and also I think you always need to decide which technology is most suitable and practical for your specific needs instead of listening to other people about their comments on specific technology, okay? So firstly, if you want to design web maps for a living, full-time, or even as a lobby, you have to learn how to read and write some code. Especially if you're trying to be a programmer, you are doing full-time job coding, then you need to be an expert. But if you only want to be a cartographer, you are not doing this for your living, then you do not have to be an expert. You don't have to be a coding master, but all you need to be able to do is learn enough code to hack other people's code, which means you need to read some programming books and also know the mechanism of a specific or several programming languages. And then you go to GitHub or other software, other websites who share people's codes. You download those codes, learn them, adjust them, and use them for yourself. It is legal to do that because all those codes shared through, for example, GitHub, they are following specific agreements and protocols. You can use them for free, but non-commercial unless you adjust them, you rewrite them, okay? And since we're talking about web mapping and dynamic programming, you need to know this. It's called Flash. Okay, so Flash is used to make web plugin. And a web plugin is an external program that is loaded by a web browser, which means that in the past, it was pretty hard to use HTML, hypertext markup language, to add dynamic elements into your website, into your web page, or into your web maps. And Flash is the savior. Okay, Flash allows you to add dynamic elements, for example, an animation, a video clip, or an audio clip into your website to make it dynamic. Okay, so essentially they are small programs, web plugins. They are small programs used to execute external non-HTML code. Okay, so it was revolutionary. And if you have been using internet for more than 15 years, you should know that in the past, a lot of small windows would pop up when you are browsing the internet, and there are animations, videos inside of all those small windows, and most of them are Flash plugins. But Flash is dying right now because a lot of people, they're using Flash to spread virus because it's a non-HTML program. You can just set backdoors and add virus into those dynamic elements. And also using Flash, using Adobe Flash will require a lot of resources, computer resources. So in summary, your computer will become slower and slower when you are loading more and more Flash plugins when you are browsing the internet. So the replacement is something called HTML5. So it means HTML language 5.0. It's a version. It's the newest version of HTML language. So HTML5 is an attempt to create a dynamic web devoid of plugins, which means you just program in your browser, okay, instead of introducing another program into this process. So the belief is that native HTML5 coding and technology will be faster, more secure, and more open. So today, if you are using Chrome, and I'm not sure about Foxfire, but they are trying to kill Flash. Because sometimes now if you're using a Chrome and you're going to a website using Flash, there will be a pop-up window from Chrome telling you that this is not safe and we're going to stop using Flash before the end of 2020 or 2021. Not sure, but Flash is not the mainstream anymore. But HTML5 itself is not good enough to build a fancy, highly dynamic website or web page, or you can say as a cartographer, a web map, because HTML5 is only for basic structure and content of your web page. For example, there should be a title, then text, then there will be a signature, then there will be another element on your website, no matter what it is. So this structure is decided by HTML5. And another language is called CSS. It is used to decide the style of your web page. Okay. For example, the color of your title, the text color, and the background color, and etc., and the shape of different frames and windows. That's CSS. And JavaScript is here to define interactive elements. For example, if there is a button, okay, so if your user clicks that button, what is going to happen? Okay, if there is a menu, what is going to happen if I click that menu? These interactive elements, they are decided by JavaScript. So usually now, if you are programming, you're trying to create a web page, HTML5, CSS, and JavaScript, usually you need to combine them, use all of them to design, to implement your web page. Okay, again, you must become familiar with all three of these languages to design web maps or web pages, but you don't have to be an expert. Okay, like I said, as long as you have enough knowledge to read other people's codes, you can just adapt, change, and adjust. Okay, and use them for yourself. Use them for yourself. So let's talk about very popular web map data formats. Okay, so we're going to introduce 5 of them. Okay, KML, GeoJSON, SVG, MapTiles, and GeoPDFs. Okay, so many of these web data formats, they're not what print cartographers and desktop GIS users are used to saying, which means they were created to adapt the era of web mapping. Okay, so the first format is called KML. It's called Keyhole Markup Language. It's an XML language, or extensible markup language, developed by Google to represent spatial data in Google Earth at the very beginning. Okay, so at the very beginning, when Google Earth started to develop, this format is exclusive for Google Map. Okay, but sorry, for Google Earth. But now, since Google is a boss of web mapping industry, so it has been more widely used in different programs. I think now ArcGIS can read KML file, and other software, I'm not sure, but KML is becoming more and more popular. And sometimes you can say a format as KMZ. KMZ is simply a zipped KML file, which means compressed KML file. So KMZ, KML, they're actually the same thing. Okay, if you compress KML file, you will get a KMZ file. And the second type I want to address here is called GeoJSON. So it has smaller size than KML, and it's pretty easy to read because KML files, they are basically organized, well-organized TXT file. So what you can say is a lot of lines with different syntaxes. So GeoJSON is relatively easier to read, okay, easier to control. So the next format is called SVG. It's also an XML image format. But the special part about this item, about this format is that it does not pixelate with resizing because they're created using coordinates in an XML file. What does it mean? It means that if you are zooming in or zooming out for raster data, okay, pixels will become smaller and larger depending on your zooming in or zooming out. So in that case, the image will become more and more coarser if you zoom in, if you continue to zoom in. And if you continue to zoom out, your image will become more and more clear, right? So if you zoom in a lot and the image is becoming more and more coarser, that is not something we want because less and less details will be shown. But SVG file has the advantage that each specific location, or you can say each specific geographic entity here in the file is defined by coordinates. No matter zooming in or zooming out, SVG file will just adjust accordingly to make sure that the detail will not be decreased even you continue to zoom in, okay? And you can manipulate and animate SVG files using JavaScript, so it's very convenient, okay? So SVG is a type of raster file. So next format, map tiles, they are for raster data. So raster data can be very large, very large. Traditionally, when you are loading a raster file to your hard drive, you load all of them. You load all of them. But map tiles, they are here to address this problem. Map tiles, this format will just divide the whole map, a large raster map, into rasterized squares, and each one can be considered as a tile. So when you're looking at a specific part of the map, only tiles inside your site will be loaded. The rest tiles, they are not loaded. So it will save a lot of computer resources, okay? And it's the same thing when you are zooming in or zooming out, okay? Different tiles will be shown according to your current site, okay? And the rest tiles, they are not in the current site, they will not be what? They will not be loaded, okay? So the drawbacks is that to host detailed tiles for large areas takes a massive amount of server space. And also if something drastic changes, huge changes with your base map, it can be time consuming to update the map. What does it mean? It means that when you are zooming in or zooming out, like I said, some tails, they will be shown. The rest of them will be hidden, okay? This process also needs time to finish, to implement. So when you are zooming in or you are zooming out, you will feel the lag because the computer needs some time to decide which part of the map should be loaded, which part of the map should not be loaded, okay? So that's map tiles format, okay? The next one is called geospatial PDFs. So PDFs, we are very familiar with that. It's an encrypted Adobe format, text format for documents, right? So geospatial PDFs, they are geo-referenced maps in a portable document format. So georeferenced maps in a PDF. Okay, so PDF is a intellectual property for Adobe, right? So they can be opened. Geospatial PDFs, they can be opened in Adobe Acrobat or any PDF viewer. Okay, so they are georeferenced and can work in conjunction with a device GPS. Okay, and because they're typically downloaded to and stored on a device, even you do not have the internet connection, they can still work with your GPS on your device. So it's very convenient for field work. If you're going to a remote place to do field work and you need a map and you will not have internet connection at that specific location, you can make your maps in geospatial PDF format and just use them and copy and paste them to your device and bring them to the field. And because these PDFs, these maps, they are georeferenced, even without internet, they can work with your GPS, So how do I create these data types? The data types I introduced, most of them can be created for free. And here we have some geographic information systems can create them. A global mapper, ArcGIS Desktop, ArcGIS Pro, and QGIS. And I think Google Earth should be a part of GIS, right? I didn't add it here, but yes, Google Earth can also be used to create KM Alpha, okay? Because it's exclusive. It was developed for Google Earth. And there are some non-GIS data creation applications. They can also be used. They can also be used to create some of the data formats I mentioned in the last several slides. Carto, GeoCommons, Google Maps. Google Maps cannot be considered as a GIS, okay? IndyMapper, MapTiler, or you can use R language to do that. And this software here, some of them are for free. For example, QGIS, Google Map, Google Earth, they are for free. But the rest of them, you need to pay some money to use them, okay? Could be very expensive, could be less expensive and affordable, but sometimes you always have to balance the investment and the convenience brought by this software, okay? Sometimes it's worth the money, but you have to consider, okay? Okay, that's all I want to say, all I want to introduce for web mapping, and thank you very much.